Okay, so I'm planning to start this dialogue sessions every week. These are like not going to be like more than 1 hour, and these sessions are really useful. Okay, and I'm 100% sure that this content, what I'm going to discuss in every week, this is completely different. Okay, so let's get into the topic. First of all, thank you so much for joining that this session, and we are going to discuss in detail of these concepts. Okay, so today, as part of this dialogue, we are going to discuss about the open source GPU data science. You know data science, you know artificial intelligence, even you know a little bit about GPUs and CPUs, but we are going to talk something little different now. Okay, and what is all about this GPU, how it's going to be important, we are going to have look into it. Okay, the first thing is first. So you should ask question, what is the difference between the CPU, GPU and TPU? Generally, these are the differences, right? Okay, so CPU stands for the central processing unit and GPU stands for the graphics processing unit and TPU stands for the tensor processing unit, right? So these processing units are there. For example, when you are working on the machine learning, right? Definitely, so generally in your local computer, you use the CPU, but when it goes to the large systems, right? Generally, if you want to do the parallel computing, then we have to go for the GPUs. And if you are doing with the very large computations and all, we have to go with the like a TPU. So this is a major differences we generally talk, right? Okay, so let me get into the topic here. So today our topic is GPU. So what is GPU? General Processing Unit. Fine. What exactly it does, basically, right? So why do we use GPUs in the data science projects in the AI programming? That's something which I am going to talk about today. Okay. The first thing is CPU mainly use it for the sequential computing and for the multi-cores, right? So generally, if you are using multi machine learning projects in your local computer, we use the sequential computing, right? So you are actually doing every work step by step, right? So, and also you have the multi-cores. See, in the olden days, we don't have this multi-cores, and anyway, Intel is bought multi-cores. Right now, we can say dual core processors and everything. And the CPU is actually having the sequential computing and multi-cores. But CPU is not capable for the machine learning projects. I mean, I need to say that large data sets, when you're working on the big projects and all, CPUs are not enough, right? We have to go for the GPUs. Why GPUs we are going for it? GPU is mainly for the parallel computing and also we use the multi-cores. Multi-cores means like multiple processors. The cores is actually related to that processor. Okay, in CPUs and GPUs, we can use this kind of concepts. Okay, and now see this GPU when you are going to use in your projects, what is the how you are going to develop the deep learning models in your computer, it's main important, right? It is not like simply you can develop the machine learning projects in your CPU computers, right? So we have to look into it, that concepts. Why do we use the GPUs? The first most important thing is speed computational process. There is a large equation, you have it, you want to implement that large equations. Okay, so that time I have to go for the large equations to build it, then I will use this GPUs. GPU is mainly for this speed computational process. And GPUs also can be used for the paralleling for the massive distributed computational process. So in shortly, I will show you some websites, some tools, some of the machine learning frameworks. You will really amazed with that, why we have to see, you know, only scikit-learn, you know, only like something like TensorFlow maximum, but there are other ecosystem which we can use it for the GPUs. So I want to talk about that one today. So that's the reason I chosen this topic. And here we'll talk about something called the modes of parallelism. What is the modes? So these modes like single instruction, single data, single instruction, multiple data, multiple instructions, single data, multiple instructions, multiple data. So what does that mean like? So these are the various parallelism techniques. The primary benefit of the GPUs is the parallelism or simultaneous processing of the parts of the whole. There are 4 architects which is involved here. Most CPUs are the multi-core processors operating with MIMD. So GPUs uses the SIMD architecture. SIMD stands for single instruction multiple data. So this difference makes the GPUs well suited for the deep learning processors or deep learning projects, which require the same process to be performed for the numerous data items. Okay, so in 2007, with the launch of NVIDIA CUDA framework, okay, this barrier was broken. Okay, so NVIDIA is bought a GPU's mechanism to implementation of this SIMD architecture, which is a really powerful architecture. And before NVIDIA, there is an OpenGL framework is there. It is basically a specialized language for the GPUs. But nowadays, everyone is going for the CUDA framework. So anyway, I'm going to talk in detail about each and every topic in shortly. Okay. So moving to the next one. Okay. What are the application programming interfaces I have for the GPUs? Okay, you are the developer, right? Okay, these are all infrastructure we have spoken so far, like CPUs, TPUs, and all. So what are the APIs I can invest my time to understand these GPUs? The first thing is, before, in the olden days, before 2000, if I'm not wrong, it is 2007. Before 2007, we used OpenGL. Now we have the CUDA, which is actually built. This is actually developed by the company name called NVIDIA, and also there is a PyTorch GPU. There is one more thing is called the TensorFlow GPU. So we have the various GPU APIs here. So TensorFlow GPU, PyTorch GPU, CUDA, and OpenGL. PyTorch is actually from the Facebook. So Facebook is providing this GPU, and the Google is actually providing the TensorFlow GPU. So these are the GPU frameworks. Okay, so for example, if you're working on the TensorFlow projects, okay, you want to develop the application on the TensorFlow, so then we can use this TensorFlow GPU. I will show you in shortly how these things can be done and how these frameworks is evolved. I will go to the websites and show you that how these things are related. So CUDA is one framework, PyTorch GPU is another framework, TensorFlow GPU is another framework, and OpenGL is another framework. The OpenGL is a little older than all these three, basically. Okay, so if you look at the deep learning projects, if you go to the organizations in future, I'm talking about in future, not now. In future, we are going to use the projects in this kind of APIs only, not like scikit-learn, something not like that. So it is going to be very hard skill in future. This OpenGL and CUDA, PyTorch GPU, TensorFlow GPUs, which we are going to use it. Okay, so moving to the next one, what is CUDA? Right, so this is basically you will get most of the times what is a CUDA, how it is going to be useful, right? So CUDA is actually like one of the parallel computing platform, and which is actually implemented by the NVIDIA for the general computing and graphical processing units. That's where this CUDA is came into picture, and the CUDA is actually stands for what is the abbreviation of the CUDA? CUDA is the Compute Unified Device Architecture, which is a parallel computing platform. And as I said, like it is created by the NVIDIA for their own GPU systems, right? Now, you may ask me the question now. So why NVIDIA is invested the time for this? You know, right? We use the NVIDIA processors for the gaming purpose, right? So if, for example, you are building a game, you want to do this so much of the floating computations and all, right? So we have to use the very high-end processors. So NVIDIA is actually built this CUDA. It is one of the framework which is built by the NVIDIA itself. Okay, so I will show you that framework, how we can write the coding and all. We'll show you that and everything. So now come to the point. If you want to build, if you want to use your own, most of the people will ask you the question, okay, what are the GPUs computers we can use? These are the GPUs computers. We can use the NVIDIA Titan V and NVIDIA Titan RTX, NVIDIA GeForce RTX 2080. These are the GPU systems. For example, you want to implement the deep learning projects or deep learning AI in your system. So you need to have this specialized configurations. Okay, for example, you are using like something called Dell computer, or like you are using something called like HP computers and all, it's okay. But if it is only dual core process, it's not going to help you. If we want something to be built, deep learning projects, big projects, something which is a very huge data sets, if you want to do it, this are the systems you have to use. This is the configurations, basically we use it. So NVIDIA Titan 5, NVIDIA Titan RTX, and NVIDIA Geo4 RTX. And these systems are very expensive. These systems are very expensive, and it is not like $2,500 or something. And mainly people use it for the gaming purpose, and also we can use it for the training the models. Okay, so if you want to train the very huge data set, like for example 10 years old data set which has so much of data, and if you want to train that, so basically we can go for this kind of systems. Okay, this is going to help you in that case. So I will show you in that websites. And you can see here NVIDIA Titan 5, which is a 32 GB and 128 GB, the range, and there is a teraflops. Teraflops means a trillion floating point operations per second. For example, if you take the CPU, in CPU basically we use very small computations. A plus B is equal to what, and a square plus b square, y is equal to mx plus c. There is a small computations we do, right? When it comes to the GPUs, we have to go for the large computations. There is so much of mathematics is involved, right? So you have to calculate the so many floating variables, floating data. So in that case, we have to use the teraflops, which is one of the concept which is there in the GPUs. Teraflops means a trillion floating point operations per second. So that much speed we need to use in this teraflops basically, right? That's where this NVIDIA is came into the picture. So moving to the next slide. What are the data center GPUs we have it? Okay, so NVIDIA is the best, the company where it is investing a lot their time into the GPUs. Okay, and NVIDIA has this NVIDIA A100, NVIDIA V100, NVIDIA Tesla P100, NVIDIA Tesla K80, and Google Tensor processing units. These are the data center GPUs basically we use when you are developing the deep learning projects. Remember guys, the content which I'm talking about, the deep learning projects, not like simple machine learning projects, not like a simple linear regression, not like simple thing, where you're building very like CNN models, RNN models, ANN models. So if you're doing such kind of things, which are larger data sets, we need these GPUs. Okay, this GPUs plays very important role. We should understand this because in future, we deal with a large amount of data only. So that time, normal computers is not going to help you. So all these computer scientists, especially who are working on this AI and data science, they have to use these kind of configurations to invest their time basically to develop the deep learning projects. Okay, so moving to the next one, the CUDA ecosystem. So today I'm going to invest more time onto this CUDA environment. What is the CUDA and how this comes. Okay, in CUDA we have the separate machine learning framework that is called CUML. Okay, QML and QDF, and also we can use this CUDA with separately with the Python. That's something we can call it as the CUDA. And also we can use if you want to accelerate your deep learning projects, you have to use Rapids. Rapids is one of the most popular what I can say that deep learning GPU API. We can use it to build these systems basically, right? So we have the QML and we have QDF and CUDA. These are the environments when you want to build deep learning projects. Okay, this is going to be a little future. So we have to invest more time to understand this, how this deep learning projects works. If we aim for the neural network engineer, if you want to build a big AI projects or something which is having the large data sets, we have to move to the different ecosystem. So if you can ask me what is the QML, basically this is something which is similar to the scikit-learn, which is something similar to the TensorFlow, right? So it is actually built by NVIDIA. So NVIDIA is actually bought this this machine learning framework, and we have so many machine learning algorithms here. Algorithms are same only, same algorithms like regression problems, CNN problems. Algorithms are not going to change, but we are implementing onto the GPU systems. Okay, that's just especially for the GPUs. Okay, so moving to the next thing. So let's see some content. I'm going to show you some content which is really useful. I'm going to show you some websites, and after this session, I will paste those website links into the video description. You can take it for your references. So I'm going to the website. So I will show you something one by one. So we will have a look into it. For example, first one, CUDA. So I'm just going to type here the CUDA. What is this CUDA? You can see this CUDA is actually this one of the parallel computing application programming interface, which is created by the NVIDIA, right? So for example, if you want to build, okay, if you want to build machine learning using the CUDA environment, we have the separate machine learning is called the CUDA ML. Okay, so not this website, guys. I just have to go to the, okay, so deep learning, okay, CUDA machine learning, and or you can say that this is a QML. You just type the QML. I miss. So I will take you to now one of the website. This is a GitHub source code. If you want to use, this is the GPU machine learning algorithms, right? So QML is a GPU machine algorithm. This is suits for the libraries to implement the machine learning algorithms functions. But when you're using this CUML, I mean QML, basically we use the Rapids projects. So Rapids is one of the most preferred GPU data science platform, where we can generally connect with this deep learning projects. So we can integrate with the Python. We see NVIDIA actually built this CUDA is for the C++, and also we can use the Python basically, okay? And one more important thing is that we can accelerate the models. If you can see, if you want to do the programming, so this is how we have to do. There is a import QDF. QDF means the CUDA data frame. This data frame is little different from the normal data frames which you use on the pandas. But of course, these are all built on the pandas only. But similar case, but these are like works on to the different environments basically. Let me go back to this. I am scrolling down this. If you want to use the QDF, you can use this, okay? You have to download the PDF. But before that, I'm going to show you something here, highlight this content. So QML enables the data science and researchers and software engineers to run the traditional and tabular ML task on the GPUs without going on the details of the CUDA programming. In most of the cases, QML's Python API. So what I'm going to say that, okay, so most of the times we use the scikit-learn, but of course, which is QML is also like, which is a flavor of this one, we can use this. For example, if you're going for large data sets, and these are the GPU based implementations, can we need 10 to 15x, 50x, more than 10 times or 50 times faster than their CPU equivalents. That time we can go for the QML. The QML is the best source to implement the large projects. Okay, this is going to be a future, right? So we need to think about beyond the not in CPU. We have to think about the GPUs. Of course, already all deep learning projects are like that only. So this QDF anyway is our part of our data science programming, which we are going to discuss in upcoming days. Each and every topic, how to create the QDFs and how to create the clusters, how to run this machine learning projects and all we can see, right? Okay, we have here, there is so many supported algorithms here, clustering, dimensionality reduction, and we have the nonlinear regressions, and so many time series problems, and many things are there. And most important thing which I'm going to tell you, if you can go and type here, NVIDIA, okay, NVIDIA Data Science, okay, NVIDIA Data Science, okay, I'm going to type here. So just go and type here NVIDIA Data Science. If you can go to their websites, I'll show you something now. Okay, if you can scroll down these websites, you can see here the exhibit training on the NVIDIA GPUs. You can see the data preparation is fast and end-to-end processing, which is very fast. And also like it accelerates very faster than the one which you work in the CPUs. And there is we have like different things here. For example, in one of the slide which I said, like, okay, if I can go back to here, the slides which I mentioned, this NVIDIA Titan 5 and NVIDIA RTX, which I will show you that what is the RTX, what is the cost of RTX, we can see now. So just you can go and type here NVIDIA RTX. This is one of the PC graphics cards. So GPU stands for that is only right graphics processing unit. So this is the mainly like Titan RTX, which we can use it for to accelerate our deep learning projects, which is mainly we can use it. Okay. And basically they use one of the architecture name is called the Turing. And so this is how this is, okay, the specifications of this, especially this is for the deep learning AI. When we are working on the deep learning AI, then only we can use this. And this is very, very faster, guys. And the cost is more, it is like $2,500 or something, okay, if I'm not wrong, okay. And there is some specifications are there. You can check out this website when you have some time. And but right now this is out of stock. But yeah, if you are interested, you can have a look into it, how this basically we can consider this point. Okay, so because these are the infrastructure tools we may consider for to build the applications. Okay, so moving to the next one. Okay, I want to show you something a little different now. Okay, so NVIDIA is also having this something something like GitHub projects. So we can say that NVIDIA GitHub. Okay, so I'm just going to say that NVIDIA GitHub. If I go and click on this, so let me go to this. Okay, so NVIDIA research projects. If you are interested on this NVIDIA research projects, you just open this and we can see there is a lot of research projects are there. If you want to test the applications on the NVIDIA, we can use this one NVIDIA projects also. Okay, this is something like you just look at this, and NVIDIA is not just only for Python. We can also use for the other frameworks, but even if you can also use the CUDA in the Python language, that can be possible. If, for example, you are choosing the TensorFlow, I'm going to say they have TensorFlow GPU. You can type here TensorFlow GPU. I'm going to now, if you are working on TensorFlow, if you want to be switched to the GPUs, and you have to install this one, you can see here, right? The pip install TensorFlow, which is 1.15. And if you're working on the TensorFlow GPUs, we can use the pip install TensorFlow GPUs. So there are various flavors we have it. We can use the CPUs and GPUs. So it's up to you. Like, for example, you are working in your own personal computer, we can go for TensorFlow. And you are working onto the GPUs environment, you have something NVIDIA systems and all, and your configurations, you have it. So we can go for this TensorFlow GPU as well. And when you are going for the GPUs, your hardware requirement is like this, guys. You can see here NVIDIA GPU cards, the architecture is something higher than 8.0, and there is a list is given. So tomorrow you might be choosing this TensorFlow for the GPUs, and these are the hardware requirements you should consider, right? So this is how this is there, and there is a software requirements. These are the drivers we need to have, and there is a Linux setup if you're choosing the Linux setup. And anyway, we are going to experience all these concepts practically in the future when I'm going to invest time and show you. But at this moment, we are just talking about what is this GPU data science, how this GPU data sciences can help us to grow in the data science community. So that's where I'm sharing with this idea. Not only this, and also we have something called Facebook. Facebook is also bought, that is called PyTorch. So I'm saying that PyTorch GPU, you just type here and it will take you to there, not Medium. I'm now taking to this PyTorch website. You can see here, and here also they use the CUDA, which is basically like a framework which we can, because PyTorch is actually Python based framework only, right? Basically, which is actually bought by the Facebook for the deep learning projects. So if you want to do the CUDA operations, okay, we can use the torch.CUDA, and we can implement the like deep learning projects where we use the tensors and all. Right. So what I mean to say that we have the, okay, if we can go to here, the one which I said, okay, let me take you. We have like these many things are there. Okay. And let me show you. Let me go to here. So we have OpenGL, CUDA, PyTorch GPU, TensorFlow GPU. But the CUDA CUDA, which is going to be our concept, I'm going to discuss in detail about this. What is the Cuml? What is the CUDA data frame and CUDA NumPy? Okay, so we are going to understand this one to accelerate our data science projects in faster way. How to implement these projects and all, we are going to have a look into it in this case. So let me take you to the some more important point here. So let me take to you NVIDIA website itself, because NVIDIA is the only company is invested a lot onto the GPUs, because those are the GPU processing units. Basically, we use that. Okay, so NVIDIA. Okay, there is a drivers. Okay, I'm talking about artificial intelligence leadership. This is okay. Okay, there is going to be one conference. If you are interested, you can attend it. Okay, I don't want your developers, blog, forums, open source portal. So I'm taking you to this open source portal. You can look at here. We have like, so here you can check this deep learning concepts. Okay, this is very important thing which I'm showing now. When you choose the deep learning, okay, so this is a really best. NVIDIA is actually the best. We can use it for this. And we can see in the deep learning, we have the Rapids. It is an open GPU data science, which is actually in the Python. And also Tensor RT, high performance platform for the deep learning inferences. And also we have NCCL and PyTorch is there, ONNX is there, TensorFlow, digits. So basically, when you are using the deep learning models into the GPUs, we can use these kind of frameworks, which is really useful to you. You can check this platform. Anyway, I'm going to give this link, especially in the our video description. You can take it from there itself. And remember, I'm talking about open source GPU data science, right? So this is also open source. So no need of paying. I mean, it's not like any premium here, right? So Rapids is also free of cost, and TensorFlow is also free of cost. PyTorch is also free of cost. And only the cost is involved is to buy the configuration systems to run these projects. And there is again, we have the container technologies, which is very popular nowadays. We have the Dockers and Kubernetes and K8 and device plugins. And like that, there are many things, even GPU monitoring systems. If you want to visualize this, we have the MDL, which is specifically for the GPUs, NVIDIA Material Definition Language, if you want to visualize the data, which is a separate concept basically we use. Okay, and also autonomous missions, if you want to make it like TensorFlow models, image classifications and all, we can use this autonomous missions where there is a components and all which is involved. We can take it where. And next one is the research. If you are interested, you can take it this, and there is some deep learning projects and deep learning examples here. You just have a look into it. HPC stands for the high performance computers. These high performance computers, we have, these are the computers if you want to consider for the GPUs. For example, if you can look at here, I'm talking about GPUs, high performance GPU data compression library. We can use this NVCOMP basically, right? So something like that. Okay, the parallel algorithms library, CUDA templates. So all these are all involved in this open source at NVIDIA. So please check these projects on the GitHub. It is actually given by the NVIDIA Corporation, and you know this NVIDIA. So these projects, you can have a look into it. There is Tableau, which is mainly used for the feature engineering and pre-processing library for the Tableau data. And also we can use the open GPU documentation if you want. So you can check this open GPU documentation. And also a lot of things are there, guys. Okay, this repository is a really great repository to look into the next level of GPUs. Okay, this GPUs really is going to help you. There is a documentation. If you want this documentation, just go and open this and have a look into it, how this GPUs document. This is from the open source documentations only. Just have a look this, okay? And you can open this and you can have a look into it. So I will share these links with you, definitely. And I'll keep all these links into the one place in our video description or like in our repositories. You can have a look into it. So the whole point is that, okay, so no more CPUs, guys. We are going to use the GPUs. We are going to use the TPUs. The processing and the infrastructure should be different. Okay, we should not use like similar things, because in future we'll have the large amounts of the data. Basically, we use the these things only, right? So we use the GPUs only, high-end systems, right? High-end computers only. So definitely in future, when you're going to sit in office, okay, you're going to use the high performance computers only, not like small CPUs, like you can work on it, because things got changed now, okay? So you should think about that in broader picture. And this is how we need to look into the like data science and AI projects, not just simply like scikit-learn and finishing at the small projects and all. Of course, those are the basics we should learn first. But when it comes to the actual implementation part, these are the concepts which we need to focus in detail, like how it help you in that case. Okay, and a lot of things are there which I am not discussing at this. I will definitely share this information in every week dialogue sessions, these dialogue meetup. In this meetup, I'm going to share a lot of interesting topics. This is just to make you an understanding that how we can get an idea how really the industries are looking for the data science and all. This is not going to be more than 45 minutes to 1 hour. Just I am sharing the knowledge to you guys. Okay. So I hope you like this session. Okay. And I hope you like this content. Hopefully. and I will share more content in the future upcoming weeks, and we'll catch up in that. Okay, so this is just like a content sharing concept, data science dialogue. And but anyway, we have actual sessions in the everyday in the evening at 9:30 p.m. IST. We'll catch up on that. We'll discuss the each and every concepts as per the plan. Okay, thank you so much for joining these sessions, and hopefully you like this content, and we'll meet up in the next week on this data science dialogue. Thank you.